So from the first class, I'm going to pick two questions from their homework. One of them is like this. If you have two sets, A minus B, is it always equal to B? It is one of the homework questions. Remember in first class, we said if you are given two sets, A and B, in general, there are four possibilities. The first one is the most complicated one, where A and B overlap a little. The second one is AB, disjoint. And then the other two is basically one contain another. Just remind everyone, a set is basically a collection of elements or a collection of items. It could be names, like Daisy, Donald, and Mickey, or it could be a set of numbers. So the way I would illustrate this is, we try to, using this diagram, to see what A minus B is, to see if it is equal to B, or is it bigger, meaning containing B, or is it a subset of B. So the first one, A minus B, which will be equal to this kind of outer part, and then A minus that, again, A minus B would be this part, and then A minus that would be equal to the red. So the red is this expression, and this red portion is part of B, so would be basically this. So A minus B is just kind of A itself, and then A minus A is nothing. So it is an empty set. So this one is this as well, meaning B contains this expression. So this one, A minus B, would be the outer kind of donut shape, if you will. And then A minus that donut shape would be equal to the inside. So therefore it is also containing it. Finally, this one, A minus B is empty because B is even bigger than A. If you try to take everything belongs to B from A, then A no longer has any items. A minus nothing will therefore be A itself. And given this diagram, the kind of shaded portion is this expression, so therefore it is part of this as well. So therefore the answer to this question is not equal. The answer is the left-hand side is always a subset of the left. The left-hand side is always a subset of the right-hand side. Can I get a show of sign? How does everyone feel about this so far? Okay. Now, I'm going to pick one more question to talk about, and this is a long one. So from the first week, there's a homework that is about reading the article, page 1 to 11, and I really encourage everyone to read that because I'm going to keep referring back to those 11 pages. So the second question I want to talk about is this. And I'm going to talk about how to approach this question in 3 different ways. And I hope the first method, everyone would basically get. And the second one, I hope the more advanced students in this class would basically, oh, okay, I see. That's what you made me to do. I didn't think about that. And the third way, I hope some of you would understand and appreciate why the third way is the most proper but the most abstract way of thinking about this problem. Okay? So the first way is pick a few illustrative values and then just kind of calculate everything. So I'm going to say, let's say A. So this choices is completely arbitrary. So let's say A is AE, B is BE, C is CE, D is D and E. Again, this is kind of what we said at the beginning of this kind of math circle. Whenever a problem is complex, try to pick something simple to just kind of try it out. So A cross B, again, thinking about the domino daisy, Mickey and duck example, is basically crossing all the possibilities. And how many are there in total? So you have AB, you have AE, you have EB, and you have EE. So this A cross B, therefore, is A cross B, A cross E, E cross B. And then similarly, for C cross D, you're just going to write it out. CD, CE, ED, and EE. And the left-hand side is this. A cross B, union C cross D. Again, what it means is we are basically combine these two into put the items from the first bag and take the items from the second bag and then put it in a bigger bag. You basically, when you look at these 8 items, does any item repeat?
Yes.
Which one?
E.
So there's only one. So therefore, when you kind of union these two, I'm not going to write it, okay? Basically, it is everything, but then this one of them is eliminated. So there's going to be that 7 items from this. Can I get a show of sign? Is everyone with me so far? Okay. Now, the right hand side, A union C is ACE. Okay. So it's basically AE, CE, union is basically like this. This is A, this is C, so A has 2 elements, A and E, C has 2 elements, C and E, therefore the union is ACE. And B union D is B, D, E. If you take the right hand side of the expression, A union C cross B union D, how many elements are there in total? So we have A, B, we have A, D, we have A, E, and what else do we have? So we basically write it out all the possibility. AB, AD, AE, CD, CB, CE, and then finally EB, ED, and EE. So if you compare this, every one of these 7 items appears here, but there are 2 items on this list that doesn't show up here. So therefore, this part is always like this. Can I get a show of sign again? Okay. So now I'm going to go to the second way of explaining this. This is where I'll come back to this. The second way I would say is pick an interpretation or application of kind of what Cartesian product x cross y is. So I think I briefly talked about it in the first class. One of the ways that people commonly explain what a Cartesian product is there's a horizontal line called x, we call it x-axis, and then there's a vertical line called y-axis. And this is the number, 1, 2, 3, 4, 5. And similarly, 1, 2, 3, 4. This does not have to be a whole number, okay? You can have 1.5, you can have 2.5, okay? And then we'll basically say, well, this point here is what we call 5 and 3. And this one is 1 and 2. You can think about going to movie theater, okay? There's a row A and let's sit 1 to 12. Basically 2 ways of describing the coordinate or the position of a plane, okay? So one of the ways to interpret what a Cartesian product is if you have a set at the beginning, which is 1 to 5, and then you have another set called called B, which is, let's say, 1 to 3. Okay. Then this idea about like taking every element to put on the first position and then picking every element in the second position basically cover this rectangle. So this region is basically the A cross B. So this is the one way of interpreting when we say Cartesian product. If both of this are, let's say, numbers, this is how we draw it. Again, you have the position where the first number is the horizontal axis. Think of it as what row in a movie theater, and then y is which seat, 1, 2, 3, 4. Therefore, if you are taking every combination of the first position and then every combination of this kind of set B in the second position, it's basically this rectangle. Okay. Now, with this, let's kind of go back to how does it help us to understand this. if I call this as A, this is B, and then I also say, let's say this as C, this as D, then let's kind of use this diagram to say A cross B is now basically this rectangle. And then C plus D is now this rectangle. And we say the union then is basically like this kind of shape. I'm going to shade it so that it's clear. So it is basically the blue. Okay. Now on the right hand side, if I first kind of combine A and C, I think I'm running out of color. Okay, let's use C. Let's say A union C, meaning combining these two. B union D, combining these two. And then we take the cross product. Then the right hand side is basically this bigger rectangle. So which side is bigger? The right hand side, the green one, because it has these two parts that wasn't part of the A cross B union C cross D. So therefore it is this. Can I get another show of sign? I expect I'm good. I expect not everyone is following this part because this part is. Okay.
But how do you know to draw, like, say, set D and B to overlap?
Good question. So it is similar to the fourth scenario. I picked the most difficult scenario. You should kind of try the different scenario as well. But usually, the more complicated and the less complicated should give you the same answer. But this is a good question.
Thank you.
Can I see the sign at the back row on this? Okay. Let me see. I'm going to not talk about the third method. I'll save it for next time. I'm going to I'm going to talk about the third method as well, and I'm going to make it quick. Okay. The third method, I'm going to say just kind of Cx cross y as it is defined. Using the analogy from the 1 to 11 pages, that second method I talk about is basically some interpretation, some application you added to the Cartesian product. When we talk about Cartesian product in the first lecture, it was pretty simple. You take the element, like Donald, Daisy, and Mickey, and then you put it to the second element, duck or mouse, okay? That plotting into a graph is something we added on top of it. So because of that, you can think about x cross y is basically a bunch of stuff here, A, and then a bunch of stuff here, which is C. And then when we say A cross B, again, thinking about the names example, is basically we are saying we are basically picking everything from A and try to draw a line or pair them up in every single possibility. Now, if I also have C and D here, then C cross D is again taking C and D and making crosses across every element and this two. And this A cross B union C cross D is basically the collection of these lines, like all the combination here, and then all the combination here. So this is the left-hand side. A cross B, union C cross D. Now on the right-hand side, on the other hand, if you draw the same diagram, again, I'm going to make it a little bit quick. What if you first union this and then union this? Then you still kind of cross everything here. But then now, because you union this B and D, you also have to cross the stuff, I call stuff, between A and D. And then you will also have to cross the pairing between B and C here. Whatever that we had before, C cross D, is still part of the line, but now you are getting this kind of A cross this part of the D, crossing this part of C to this part of B, that did not exist in the original diagram. So that's why this way of A union C cross B union D is always kind of bigger than the left-hand side.